All right, I wanted to do one that had some variables in it. I don't want to do all of them, but definitely want to do some. Now, if you have something like the cube root of 375 a to the fifth, one thing we can do is, and this is what I would advise you to do on something like this, is go ahead and let's prime factor the number 375. We know 5 divides into it because it ends in 5. That's going to be, what, 75? Yeah, that would work. Okay, now 75 is 3 times 25. So far for primes, we have 5 and 3. And then 25 is 5 and 5. Okay, so I have 3 copies of 5 and a copy of a 3. Let me just write the 3 first. 1, 2, 3 5s. All right, and so you can already tell what's going to come out here. I have 3 copies of 5, so a 5 is going to come out front. And we're going to have a 3 left on the inside. It's the number part. Now look at the a to the fifth. What I could do here is write all those. I could write 5 a's out. And I'm going to do that just to explain it. It's hard to read those a's, but here's 3 copies of a. So I know an a can come out front here, and I'd have 2 left over. Now there is a faster way to do that, and it is to say, look at your exponents. I had the cube root of a to the fifth. We know that there's 1 3 in 5, so we take an a out, and then there's 2 left over. 5 minus 3 is 2. So we're basically subtracting our exponents. We say there's 1 3, so take 1a out. And what is 5 minus 3? It is 2. So on the part left under the radical, we would end up, we'd have the 5a on the outside, and then the cube root of 3a squared. 5 minus 3 is 2. So you can subtract your exponents. You can say how many multiples of 3 are in 5, just 1, and then you have 2 left over that couldn't come out. So that's how you do 41. And look at, let's look at 43 because it's got a weird looking answer on it. It's the square root of x squared over y cubed. Now, they only have a positive root on the outside of this. Had they put a plus or minus on the outside, we wouldn't have to do this. But they've got the square root of x squared over y cubed and nothing on the outside. That means they only want the positive root. So we can split this up and we can say square root of x squared over square root of y cubed. Now, because they only have the positive root, they want the absolute value of x. That means they only want the positive values of x on the outside. And now so that's when you take your square root of x squared. We normally would have put x, but since they want the positive root, they only want positive values of x. So we'll just put the absolute value on it to make sure that we only get the positive values. Now let's look at the square root of y cubed. I know that if I've got the square root of y cubed, I can write y, okay? And I see that there's 2 copies of y that can come out. So I'm going to bring it on the out, and then I've got the square root of y left. Let's see, is that right? Do they do anything else with it? I'm just looking to see what weirdness they do with it. Okay, yes. All right, so now right now there's a square root on that y on the outside, okay? But it's going to go away. So this is not the answer they have in the book yet, but this is a step toward getting the right answer. Because it's a positive root and I took a square root, I want the positive value of y on the outside. So far I have this, right? Absolute value of y times the square root of y. Now, I want to get rid of that radical in the denominator. So I'm going to multiply. I need another square root of y. Because I want to get rid of this square root, okay? So if I do it to the denominator, I got to do it to the numerator. Now, on the top, what I have is the absolute value of x times the square root of y. On the bottom, I have the absolute value of y times absolute value of y again. Since there's 2 y's, it doesn't matter whether they're negative or positive. When I multiply y times y, I get y squared, so I don't really need the absolute values anymore because I know that no matter whether it was negative or positive, since it's got an even exponent, it will turn out to be positive. So the absolute value brackets are a little redundant here. But I still need the one on the top, and you'd have the square root of y. Here's your answer. That's what you're going to see in the book. That's a little confusing, and it has all traces back to the fact that when we take, if they have written the square root for us, that means they only want the positive root. And so if you were to plug a negative x in there, they'd want you to get a positive root out of it. We go square it, you're going to lose the sign on it. If you were to plug a negative x in here on the very first step, once you squared it, you would have lost the sign to it. And they just want, basically, we just are trying to ensure that we only get positive values of x there because of the way they wrote the problem. And that's a little confusing, I know. Since I have time, I'll do one more just in case you had a hard time with it. All right, on square roots, we have to worry about if they just write a square root, we have to make sure we're only getting positive values out. But on cube roots, we don't need to worry about that because we only have one answer when we take an odd root, or a cube root in this case. So here's what I can do. I can split this up into the top and the bottom. Give each one the cube root to try to simplify it. One thing that I kind of did mentally before I did this that I didn't mention is, before you split it up, look, is there anything you can reduce in that fraction? There's not. That's why I didn't put it, that's why I went ahead and split it up, is I couldn't see any way to reduce it with it the way it was. So now I'm going to go, okay, well, let me start working on these little parts here. So each one gets a cube root. Now, the cube root of 27 is 3. Remember, once I write it like that, let's look just at the numerator. I could even split it up further and say that's the cube root of 27 times the cube root of a. And I'll just work on that piece for a minute. We'll go ahead and simplify that much. Well, the cube root of 27 is 3, and I have a cube root of a. There's nothing I can do, to get that a out, so I'll just leave it that way. Let's go back and look at the denominator now. So we got the cube. Let me change colors so you can see, catch where I'm going, since I can't really point to it. I'm at this cube root. Let's see. I messed this up. Let's see if I can fix it. Okay, we'll try fixing it now. Sorry, I messed up a little bit. I'm at this cube root of 4b to the 4th. So let's split it out. That's the cube root of 4. Then take the pieces and split them up, times the cube root of b to the 4th. Okay. Well, I can't do anything with the cube root of 4. Now, the cube root of b to the 4th, I could say, hey, there's 4 of these under here. 3 of them would make a set that could come out, because I can take a b on the outside. In other words, there's one set of 3 in this 4, and then there'd be a b left over. So I've got a cube root of b left over, and I've still got that cube root of 4. Okay. So now, let's put that back together again, because we're going to have to do something to get rid of those radicals in the denominator. So we have the cube root of a, 3 times cube root of a on top, and on the bottom I have b times the cube root. I can put those back together and put the 4b together now. All right, the problem is we got the radical. We got the cube root of 4b. We need to get rid of it. It's considered bad form, right? So I need 2 more copies of the cube root of 4b to get rid of the cube root of 4b on the bottom. But if I do it to the bottom of a fraction, I got to remember to do it to the top, because I'm trying to keep my fraction equal. If I do, I want equal fractions here. All right, now how did that help me? Well, on the bottom, I now have 3 copies of the same thing. So that means that in the bottom, that there was the b out front, and then now I got the 4b. Remember, we're multiplying. I've got the 4b that I've got out of the radical now. So let's look at the top. It's got a lot of stuff going on with it too. We got the 3 out front. Now, if I put all this stuff together under one radical, I've got an a. Let me circle and write in green so you can see what I'm doing. I've got this a I'll put here, and then I've got a 4b. If they're multiplied, I'm just going to smush them together. And I got another 4b. Is there anything I could get out of that to, pull anything out of that radical? No. So I'm just going to have to kind of condense it now, okay? So I've got the cube root, and since I can't pull anything out, let me put the number part first. 4 times 4 is 16. And then I get 1a, and I've got 2b, so I'll write b squared. And on the bottom, I have b times 4b, which is 4b squared. We looked to see, was there anything that could reduce on the outside? No. So we are finally done. Long problem, but it's just a little piece at a time.